Hello everyone, my name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. So in this video, you're going to see about the lecture series of the subject 23 CST 205 Object Oriented Programming, Unit 5 Multi-Threading, topic Thread Life Cycle. So understanding thread life cycle and methods. So you're going to see about the thread states, core methods, real world example and best practices designed for engineers seeking clarity and confidence with concurrency. So quick recall. Multi-threading allows multiple lightweight threads to execute concurrently within a single program. So sharing memory but running independently. So typical use, a web browser loading images, videos and scripts at the same times. So why it matters? So it improves responsiveness and throughput by overlapping input and output. So next, where it is used. So servers, UA apps, games, background jobs and real-time systems. So empathy. Why care about thread lifecycle? So threads are the backbone of responsive software. Mismanaging states leads to deadlocks, race conditions or wasted CPU. So poor UX, outages and hard to find bugs. So understanding the life cycle reduces frustration and increase predictability. So defining the thread life cycle. So the canonical states and transition every developer should know. So new, runnable, running, block, waiting, timed waiting or terminated. So these are the stages of the thread life cycle. So in new state, the thread is created but not started. So in runnable, it's ready for CPU scheduling. So in running, the thread is currently executing. So blocked or waiting, it is passed awaiting resource or condition. So timed waiting for a specific timeout, either sleep or timed join. So terminated, finished execution. So ideate, key thread methods and their roles. So the first one is start. So the start method moves thread from new to runnable and triggers execution scheduling. So sleep, put thread into timely waiting for specified duration, useful for rate limiting and back off. So next one is wait or notify, coordination primitives for producer consumer patterns. Wait releases lock and passes until notify. So join, blocks current thread and until target thread finishes, ensures ordered completion. So interrupt, signals a thread to stop waiting or to perform a cooperative shutdown. Must be handled safely. So is alive, QE to check whether the thread has started and not yet terminated. So thread states in action, practical scenario. So new state spawn background file downloader. So runnable state, multiple rendering threads queued by scheduler. In running, processing user inputs, events. Then in blocked state, it's waiting for DB lock or input output. So timed waiting, retry delay with sleep or timed join. So in terminated, completed rendering of worker finished job. So managing thread priorities. So the priorities 1 to 10 influence scheduling order. Default is 5. Higher priority threads often receive more CPU time, but scheduling is platform dependent. So not a strict guarantee. So use priority to favor latency sensitive tasks but avoid starvation of lower priority threads. So common pitfalls and best practices. So avoid deadlocks. So prefer locking, ordering and timeout strategies. So minimize scope of synchronized blocks. So use join wisely. Ensure threads complete before shutdown but avoid blocking user interface threads. So prefer wait or notify. Avoid deprecated, suspend, resume, favor high-level concurrency utilities when possible. So handle interrupts. So catch interrupted exception, restore interrupt states if propagating and support cooperative cancellation. Summary. Why mastering thread lifecycle matters. So mastery of thread states and methods leads to safer, faster and more reliable software. It simplifies Debugging improves resource use and is the foundation for scalable concurrent systems and modern concurrency frameworks. So next steps, practice with small concurrent tasks, then move to higher level construct thread pools, executor reactive streams. So puzzle, what is the initial state of the thread when it is created but not yet started? So there are four options. So first one is new, runnable, second one is runnable, third one is blocked, fourth one is waiting. So the correct answer is option A, new. So these are the few references. Thank you.